Hello! Today we are going to solve this interesting equation regarding real numbers x. I'll give you 5 seconds to solve it. And then I'll proceed with my own solution. Okay, so first thing I would consider doing is to introduce a substitution in a form of u to the 5th power equals x to the 5th power plus x minus 1. So basically this first root, and v to the 5th power, let it be equal to x to the 5th power minus x plus 1. Using those substitutions, we could rewrite the given equation as u plus v equals 2x, while also adding those two, we would end up with u to the 5th power plus v to the 5th power equals 2x to the 5th power. I'll write it here. And we will be working on those two equations. Let me give you one hint, which will be drawing this pyramid. What should we do next? One, 5, 10, 10, 5, 1. So basically the sum of two immediate upper numbers, like this, for example, or like that. What is it used for? For example, x plus y to the power 3 equals x cubed plus 3x squared y plus 3xy squared plus y cubed. And you should notice that this is corresponding to this row. The coefficients in front of x and y powers are corresponding to this row. So this will come in handy when we try to calculate u plus v to the 5th power. And this thing should be equal to 32x to the 5th power. So let us write an equation like this. Multiply this firstly by 16, so that we get 32x to the 5th power also here. And write it. 16 u to the 5th power plus 16 v to the 5th power equals. Okay, now rearrange, add everything or subtract everything from the right side to the left, and we'll end up with something like this. Divide by 5v to the 5th power. Why so? To get a polynomial equation with one unknown. For this, we also need to assume that v is not equal to 0. We should also check if v equals 0 is a possible solution. If it is, then we shouldn't just straight up cross it out. Yeah. We should also include it. So if v equals 0, then look at this. U plus v equals to x. So u equals to x. But then what? U to the 5th power plus v to the 5th power equals to 2x to the 5th power. So u to the 5th power equals simultaneously 32 x to the 5th power and 2x to the 5th power. From this we get that 30 x to the 5th power equals 0, and so x equals 0. But then v is not equal to 0. So that's a contradiction. Okay. Let's focus on solving this equation. We will get 3 u over v to the 5th power minus u over v to the 4th power minus 2 u over v to the 3rd power minus 2 u over v squared minus u over v plus 3 equals 0. Then maybe for the simplicity, introduce another substitution, which is, for example, t equals to u over v, and then we have 3 t to the 5th minus t to the 4th minus 2t cubed minus 2t squared minus t plus 3 equals 0. To solve this, we don't have formula as, for example, for quadratic equations or cubic equations or even quartic equations, which is 4th power, 4th degree polynomial. For this, we have to be smart and try to figure out 1 or 2 or even 3 solutions by ourselves and divide this polynomial. What I like to use is to make this table. I'll write always 3 here and try to guess a solution, which means a number that will make this equation or this expression on the left be equal to 0. What number can it be? And we should try to guess the simplest solutions. For example, 0. We should see that 0 will give us the result of 3 at the left side, but maybe something like 1. Let's try it. Then the process goes like this. 1 times 3 plus minus 1 equals to 2. Then 1 times 2 minus 2 equals to 0. Then 1 times 0 minus 2 equals minus 2. 1 times minus 2 minus 1 equals minus 3. And we get a solution if and only if in the last cell here we get a 0, which we get. This means that the equation star could be rewritten as t minus 1 times 3t to the 4th power plus 2t to the 3rd power minus 2t minus 3 equals 0. And t equals 1 is a solution. Let's find another one. And we could also try one more time 1. Always rewrite the first number. 1 times 3 plus 2 equals 5. 1 times 5 plus 0 equals 5. 1 times 5 minus 2 equals 3. 1 times 3 minus 3 equals 0. This could be also rewritten as t minus 1 squared. 3t to the 3rd power plus 5t squared plus 5t plus 3 equals 0. Let's guess one more. 1 will not cut it. 1 will only get positive ingredients, so it will not be equal to 0. Maybe let's try minus 1. Minus 1 times 3 plus 5 equals 2. Minus 1 times 2 plus 5 equals 3. Minus 3 plus 3 equals 0. So we can rewrite this one more time. Three t squared plus 2t plus 3. And this quadratic term will have no real solutions. So our only solutions for t are either t equals 1 or t equals minus 1. And let's check it. This is the first and second possibility. Okay. Either u equals v or u equals minus v. If u equals v, 2u equals 2x. Then, if u equals x, u to the 5th power equals x to the 5th power, which is equal to x to the 5th power plus x minus 1. X minus 1 is equal to 0, so x is equal to 1. And in fact, from this we can see that u will be equal to 1 and v should be equal to x to the 5th minus x plus 1, also 1. Yes, so there is a solution x equals 1. The second possible solution is u equals minus v. Then u plus v equals to 2x. So 0 equals 2x. And x equals 0. From this, we have that u is equal to minus 1. And v is equal to 1, which is minus u. X equals 0 is also a solution, and those are the only solutions for the given equation. Thank you for watching, and feel free to send your own solutions, your own ideas and problems for me to solve. See you in the next video. Goodbye.